Here are the solutions for the recently concluded NEET test. Well, kids, you are NEET aspirants. You know most of the questions are either straight from NCERT concepts or formula based. Not much application oriented questions shall ever be asked in NEET. So, with this context in mind, let us approach the paper. For instance, for the very first question, the 91st one, there is an electric dipole placed at angle 30 is given, torque is given, find the charge on the dipole. This is a NEET previous year question. In fact, this is a NEET present year question too. It is not a PYQ as in previous year. This has been asked in NEET 2023, present year also. So what would be the answer to this? Well, the relevant formula is how can you relate theta, E, tau, etc. Only one formula. Tau is PE sine theta. Widespread misconception once again, alert, is P is q into distance between the charges, and that straight away has been given as 2 centimeters. Please do not mistake A as 2 centimeters. A is just a convention, whereas the actual formula for dipole moment is charge into distance between the charges. The distance itself is given as 2. So the dipole moment is given by simply QD, right? And tau value is given. Tau value is given as 4. Put all the numbers. So how to do it mentally? See, I'll just give you a glimpse of how it runs through my mind. Tau is 4. In P, there is also a 2. In E, there is again a 2. And sine 30 degrees 1 by 2. So this goes away. 2 cancels with 4 as 2. So irrespective of the units, all are milli, the answer should have 2 in it. So the answer is 2. 91 goes with B. Second one. The field increases at a uniform rate along positive x-axis, topic dipole once again, and the force experienced by a dipole in a non-uniform electric field. Why? Since the field is increasing at a uniform rate, field is not a constant. So how do you see whether it will move towards positive or negative? You can use elimination strategy here quite well, because if you can eliminate two, nothing like it. First of all, would it undergo a clockwise rotation or anti-clockwise rotation? Of course, clockwise. We have discussed this trick in the class. Whenever you have a dipole, just consider the positive charge and consider a direction in which electric field is shooting at the positive charge, right? So here electric field is shooting in this direction, positive direction. Therefore, the dipole would spin anti-clockwise. So dipole shall rotate anti-clockwise. So A and B gone. Either it is C or it is the D. Which of these is it? Right? Obviously, the answer, right? You can see that plus Q is behind minus Q. Plus Q is behind minus Q. In the sense, field experienced by this is E1. Let's say field experienced by this is E2. I can definitely say E1 is less than E2. Sir, वो कैसे? Because the field is increasing along positive x-axis. So field, as I go in the direction of x-axis, field decreases. Field increases. So E2 is greater than E1. Therefore, force experienced by minus Q will be greater than force experienced by plus Q. So the net force acting on a dipole is in a negative direction with an anti-clockwise rotation. Therefore, the right option is D. Well, you need to see how the field is increasing. The field is increasing in the positive x direction. Therefore, whichever charge experiences greater field, the net force on a dipole will be in the in the direction of the force experienced by that charge. For example, here minus q is experiencing greater force. So the net force acting on a dipole will be in the same direction as the force experienced by minus q, which is towards negative. direction, because we know all charges experience force in the opposite direction of the field. Field is positive, so force should be in the opposite direction. That's 92. 93. I would say it is a very easy question. See, net electric field inside a solid conductor is always zero under electrostatic condition, direct NCRT lines, property of a conductor. Under electrostatic condition, there will be no free electrons inside a conductor. This is absolute nonsense. Why? Because just because it is electrostatic condition, the free electrons won't disappear. It's just that the net field cancels. So this is incorrect statement. There will be free electrons. Free electrons won't evaporate outside a conductor. Charge conservation. Free electrons will be there inside only. Therefore, reason is wrong. Reason is wrong. So therefore, it is C option. Assertion is true. Reason is wrong. Field is zero not because there are no free electrons. Field is zero because the total field becomes zero because of the induced charges. That is a property of a conductor. That is question number 3. Now, question number 4. Wow. It says about potential, and one more clue is both are copper spheres. So first hint is they are a conductor, pair of conductors. Well, one is solid, other is hollow. फर्क कुछ भी नहीं पड़ता because the charges reside always on the surface of a conductor only, right? Surface of a conductor. Same size is same, so both of them have same R. And what is the potential? Potential is always given by V equal to KQ by R for conductors because there is no charge on the inside. So it can be treated as a point charge placed at the center, conducting spheres. Both of them are charged the same potential. Both of them have the same size. So by this relation, both of them should have the same charge. Therefore, charge on both spheres is equal. Question number 95. Here there's a plate of capacitor, parallel plate capacitors. What is the field line between them? But with an uncharged sphere of metal being inside. Okay. So, well, it can not be this. I'll tell why. Because a conductor always changes or modifies the field around it. This can also not be the reason because of the same thing. Conductor modifies the field lines around it. Either it is A or it is B. Now, what would be the correct option? We know that this can't be right. The reason is the field lines are always curved, right? The field lines won't be deflected right like this straight by a conductor. Field line will always be curved in the presence of a conductor. One more reason is if this is a conductor, field line should always be perpendicular. Field lines should be perpendicular to the surface of a conductor. These lines are not perpendicular, whereas these are perpendicular. So that this is not the right answer. Right answer is A. 95 goes with A. Again, it is a property of a conductor which comes to our rescue to answer this question. 95 goes with A. Now 96. Right. In 96, there are a lot of charges, it seems. Origin over here at 1, at 2, at 4, at 8. There are charges of magnitude Q. What is the intensity at O? Again, superposition principle to a rescue. The trigger word is superposition whenever there are multiple charges. So what to do? What would add the field due to the individual charges? The total field is E net is equal to KQ by R square, R1 square, which is 1 by 1 square, plus 1 by 2 square, plus 1 by 4 square, so on. I have taken KQ common because each of the field will have KQ in it. All right. So each of the field has KQ in it. Look at all the options. Be slightly clever over here. Don't work out this. No need to work what this is. See, it is 1 plus something. So whatever this is, it shall be greater than 1. And this K is 9 into 10 power 9. If this whole stuff is greater than 1 and k is 9 into 10 power 9, so whatever the answer is, it should also be greater than 9 because 9 is getting multiplied with something greater than 1. So 9 into something greater than 1 should be greater than 9. Look at the options. Which of them is greater than 9? Only A is greater than 9. Therefore, 96 goes with A. No need for calculating 1 by 1 square plus 1 by 2 square plus 1 by 4 square, so on and so forth. But for your knowledge, you should know that this all, whenever you see such series, it will be a GP, geometric progression, infinite. There's no end to there's no last term you can see. So for an infinite GP, the summation sum is always given by A by 1 minus R, where A is the first term of the GP. R is a common ratio, which you will get by dividing the second term by the first term. Here it is 1 by 4 by 1, or it is 1 by 4. So R is 1 by 4, A is 1, you get the summation. Then you can continue with your uh, calculation and algebra. That is question number 96. Now, question number 97. Again, electric dipole, our old friend visits us. Electric dipole placed at an angle 30 degree to a non-uniform electric field. What will happen to the dipole? Well, it is non-uniform, so it will experience both torque and force. So the option should be 97C. If you are born as a dipole, your fate is to experience a torque. But the whether you will experience a force or not, it depends on external circumstances or the field, right? If the field is uniform, force is zero. If the field is not uniform, force is not also zero. So it experiences a torque as well as a force. Now going to question number 98. Two identical pendula. We have discussed the case in the class, right? Now two identical pendula, which means they have same length and same mass. No matter what charge you give on them, each of them will experience the same electrostatic force, right? Because it's by Coulomb's law. Every action has an equal and opposite reaction. Yes, this has a different charge, this has a different charge, but the force is given by K, Q1, Q2 by R square. This force is the same for both of them in different directions. Well, so if both of them have the same mass, and it experiences the same electrostatic force, there is a relation which says tan theta should be equal to tan theta should be equal to Fe by mg. A useful formula because NEET panel has asked this question multiple times. Tan theta equal to Fe by mg. Fe and mg both are same for both of them. So this angle theta will be same for both of them. So theta 1 equal to theta 2. Okay. Now question number 99. Point charge inside just a conductor. Look at the keyword, conductor. Field inside a conductor is 0. And where is the point charge placed? Point charge is placed in the conductor. One case, because inside field is 0. If field is 0, the force experienced by the point charge will also be 0. Therefore, what will happen to a poor point charge? No force. It can't move, so it shall remain stationary. So 99 goes with D. Well, what about question number 100? Question number 100 is there in our CET module. If you have bothered to look at it, we have discussed the question in the class also. Here, what happens is I need to rank it, right? So again, the trigger word is superposition principle. Let's see. The field over here due to 2q is in this direction, due to minus 3q is also in the same direction, due to 5q it is down. So what does the first one say? First one says this, this, and this. Let's keep that in mind. Second one, how does arrows look in second one? Both arrows cancel. The only arrow is pointing down. Third one, in third one, The vertical arrows cancel, and horizontal arrows are also facing each other opposite. The 3q1 is dominant, 2q is not, because the distances are equal. They're given in the question. All charges are the same distance. Therefore, 3q field will be stronger than 2q. So the net field will only be in this direction. The vertical field cancels. What about this case? This case is legendary because all the damn arrows cancel. You can see same charges, same distance, all the arrows cancel. So which one of them from the least to highest? Which is the least? Of course, 4 is the least. Which is the highest? Of course, 1 is the highest. Between 2 and 3, which is greater? Let's go to 2. In 2, the charge which is producing the field is only 5q. But here, if you take the net charge, it is only q. 3q and 2q are acting in the opposite direction. So net effect will be only due to q. So therefore, 2 field will be higher than the third field. Therefore, 4, 2, 3, 1 is the answer. That is question number 100. Question number 101. It is ambiguous. I agree the distances are not given so properly, but the concept is this. We know that electric field lines, if they are farther apart, then the field is weak. Therefore, electric field lines being farther apart means field is weak. If they are crowded, if they are dense, there the field lines are strong. Based on this concept, you can crack this question. If the lines are too closely spaced to each other, then there the field is great. For example, I can say that if this distance is small and this is greater, I can say EA at this point EA is greater than EC. Right. So that is how we go on interpreting non-uniform electric field lines. Density of field lines. Now go to question number 102. Right. In question 102, where is a net force, net field at O act? The force on a charge Q kept at O. Okay, there is a force of Q kept at O. In which direction is the force here acting? Well, let's consider again superposition. You see how dominant a role superposition plays in arriving at answers. Between this Q and this Q, the total force would be pointing this way. Between this 3Q and this Q, the total force will be pointing this way. But since the charges are equal, the distances are also equal, the forces are opposite in direction, I can say that the total force due to plus 3Q plus 3Q goes away. I only have now force due to minus 2q and 2q. The force between plus 2q and 2q is in this direction because they repel. But these charges are like q and minus 2q, so they attract. So the total force due to plus 2q and minus 2q acting on capital Q is towards C. The total force should act along the diagonals AC. Question number 103. Again a dipole. Torque on a dipole. You should get good vibes here. Torque equal to P sine theta. Maximum torque mane sine theta is 90 degree. So sine theta becomes 1. So it is just PE, right? P is 1 into 2 into 10 power 5. Which of the options have 2 in it? Which of the options have 2 in it? But you should be careful. It is 1 micro and 2 centimeters. So 10 power minus 6 into 10 power minus 2, it is 10 power minus 8. So 10 power minus 8, 10 power minus 8 into 10 power 5 is 2 into 10 power minus 3. So the option is 2 into 10 power minus 3. Right? So wherever you see, don't do much of number work. If you see 2 coming in the answers, mark wherever you see 2 in the options, you please mark that. Okay, that is how you save time. Question 103. Now question 104. A spherical conducting shell has a charge Q. Hold on. If it has a charge Q, the charge Q will always stay on the surface properties of a conductor. If a point charge q is placed at the center, then I place charge q at the center. Due to induction, minus q appears on its inner surface. On the outer surface, plus q appears. Charge neutrality, you see. Now what's the total charge on the outer surface? Small q and capital Q put together. So outer surface should have q plus q. So this is gone. This is gone. So between B and D, inner surface charge should be negative induction. So it should be D. 104 goes with D. Now 105. Rank the situation according to the magnitude of electric field at the points from greatest to least. The charges are only on one surface. Regardless of that, basic elementary formula, which is sigma by 2 epsilon naught. Right. Now you see, at point 1, due to, and again, I should say this should belong to superposition principle because there are multiple sheets. Great role, isn't it? Superposition principle is literally everything in electrostats. What is the total field at point 1? Field at point 1 will be due to this sheet, which is pointing in this direction. Field due to this sheet, which is also pointing in this direction. What is the field due to point 4? Due to field at point 4. At point 4, field due to this sheet will be over like this. Due to this will be over like this. Both of them will cancel each other because for a sheet, field is independent of distance. So the location of the points, distance of the points from the sheet really doesn't matter. Location matters, whether it is on the right or left, that matters. But the distance doesn't matter. So 4 and 5, for both points, 4 comma 5, I can say that the total field is 0. Reason is the field is independent and the fields are always directed opposite between the plates. Both have same charge on that. So 4 and 5 should be a tie. Which of the options says 4 and 5 a tie? This says, this says, right? Um, well, they say least to the greatest magnitude. Isn't 0 the least positive number? Hmm. So 4 and 5 should actually come at the first, least, because 0 is the least. Therefore, C should be the right answer. I don't even go and look at 2 and 3. I don't need to do that. See how much I save time. That is question number 105. Because 0 is the least positive number. Now, question 106. Question 106. Well, this requires a lot of thinking. There's a charge Q1 it is kept at a distance of y, whereas charge Q2 is at a distance x. What is the value of x for which the horizontal component of force acting on Q1? You see, Q1, Q2 are like charges, so they repel. The direction will be like this. Horizontal component means if this is theta, this angle will also be theta. Let the force be F. I need F cos theta to be maximum. All right, that's it. And what is fixed? Y is fixed. Y wala distance. Well, since the answer doesn't depend on Q1, Q2, and K, I won't really go into there, but I'll just put the distance between Q1, Q2 as R. F is proportional to 1 by R square multiplied by cos theta. I basically want at what distance X is 1 by R square cos theta the maximum. Can you get the question? At what distance x is this expression 1 by r square cos theta is 90? Well, we can do this by, you know, uh, looking at this. Look at all the options over here. Well, two are repeated, of course. Ignore it. Look at all the options over here. They have a linear relationship between x and y. How about taking y by x ratio as some standard quantity? See, from the first one, from the first option, y by x will be 2. Second option, y by x will be root 2. Fourth option, y by x will be 1 by root 2. So if I somehow find out the y by x quantity, then I can find the answer. Then I can find out the correct answer. Y by x quantity, how to find it? Well, I know y by x is nothing but tan. Y by x is tan, right? So somehow I need to have tan theta in the expression. Well, that is one thing. The other way is I can put r square. What is r square? Square of the hypotenuse. Sum of the squares of the opposite side. And what is cos theta? Cos theta is this, right? The side is root of x square plus y square. So cos theta will be x by root of x square plus y square. So what is the ultimate expression? Ultimate expression is x by x square plus y square times root of x square plus y square. This is for what value of x is this expression met? Such a long question. This can further be simplified as x by x square plus y square whole power 3 by 2, because this is x square plus y square power 1 by 2. 1 by 2 plus 1 is 3 by 2. For what value of x is x by x square plus y square power 3 by 2 the maximum? So much information I need to find out. One straight away thing is you do df by dx equal to 0. Take the whenever you need to maximize anything with respect to the variable, take the derivative of that anything with respect to that variable equal to 0. So I will have to take this derivative equal to 0 and then arrive at the answer. Quite lengthy, isn't it? So you'd actually ignore this question and not attempt it. Right? Now, question number 107. In question 107, there are 3-point charges placed at vertices of equilateral triangle. A fourth charge Q is placed at the center such that the charge remains stationary. So what is the value of Q? Uh-huh. Um, so there is a problem over here. The problem is there is no unique value of Q, isn't it? You look at it. Q, Q, and Q. All three charges are same. So at the center, it's equilateral triangle though. So at the center, the field due to these charges is 0. So no matter whatever charge, 1 coulomb, 2 coulomb, 3 coulomb, 4 coulomb, whatever x and y coulomb, whatever charges you keep at this point, the force experienced by that will be 0. Isn't it? The field itself is 0. So there is a no unique value of Q which will remain stationary at the centroid because the total field at that point is 0. If the question modifies to the the system of charges remain stationary, if this whole system remains stationary, then it changes. So if let us assume that they're asking what is the value of the small charge q such that the system of charges remains stationary, then all 1, 2, 3, 4, all the 4 charges should remain stationary. Now, how can that happen? Let us take any one charge, for instance. What is the total force experienced by this charge due to the other two at the vertices? Repulsion, repulsion. So the total due to these two will be somewhere like this. This force has to be balanced by an attraction. So whatever charge you place at the center, it should be negative. Which of the charge is negative? Options, which is the option is negative? C is negative, hence C is the right option. So even if the question was system of charges remain stationary, then also it would be done very easily if you look at the options with wide eyes, alert eyes, awake eyes, right? because the charge has to be negative to balance the total force acting on capital Q. So that is 107. Now we go to question number 108. Question number 108 is rather a very, very standard case. You see, there are two similar balls, question 108, two similar balls. They are hung, the length of the threads are L. Separation between the ball, they're asking what is the value of X. Theta is small, it says. So this angle is very small. The separation between the threads is small. So the angle is small. So I can assume even this angle is small. I'll call this as theta. That is earlier I gave you a trick. Tan theta is Fe by mg. So what is Fe? Fe is kq square by x square by mg. So this is what it is. Further, what is tan theta? Tan of this angle. Tan of this angle is this distance by this distance. But if theta is very small, I can say that this perpendicular distance is almost equal to the hypotenuse. Therefore, tan theta is equal to x by L. Tan theta is equal to x by L. So x by L is equal to kq square into mg by x square. I'm least interested in these quantities because they don't have any relevance in the option. I am also least interested in the L quantity, not relevant to the option. I can simply equate all of them to 1 and move on. X cube is equal to q square. So what does x depend on? X depends on q power 2 by 3. So the answer is x depends on q power 2 by 3. So where does it go? It goes over here. X depends on q power 2 by 3. Okay. The other options are m minus half L cube q square. Well, look, if you're a NEET candidate, you should look at which options are most repeated. Which options are most repeated? Here there are the options on Q and Q, most repeated. So the answers are 99.9% less likely to be these. That's why I just considered the Q relation. Otherwise, what would be the right answer? Separation X is proportional to Q power 2 by 3. It is proportional to M, mgm, and it is also proportional to direct L. These are a set of quantities which X is proportional to. But I haven't considered M and L over here because they are unique, whereas A and B are repeated. Wherever choices are repeated, in NEET 100% between the two options, one will be right. So 108, that is the case. What about 109? 109, quite an ordeal because it is Coulomb law, magnitude of electrostatic force, charges is given, but distance between the charge is not given. They have given the position of the points, right? So how to deal with that then? So 109, the position of the points is given. Origin is over here. Point number 1, point number 2 is here. One point like this, other point like that, right? So these vectors are given. R1 vector is given. R2 vector is given. But for the force, what do I need? Well, let's think. For the force, I need the distance. This How do I get that distance? By vector addition, that distance d is magnitude of r1 minus r2 vector. That distance is a magnitude of r1 minus r2 vector. I subtract the vector, take its mod, that is distance between the charges, shortcut. So distance, subtract the vectors. 2i minus I gives you only I. 3j minus j gives you 2j. K minus 3k, it will be minus 2k. Take mod of this. So mod of that would be square root of 1 square plus 2 square plus 2 square. So totally 4 plus 4 plus 1, 9. 9 ka root is 3. Right? 9 ka root is 3. That's it. So 3 meters is the distance between the charges. So what would be force? Force is k, q, and q2 by r square. So 9 into 10 power 9 into q1, q2. So it is 10 power minus 6 into 10 power minus 6 by r square, which is 9. 9 and 9 gets cancelled. 10 power minus 9 into 10 power minus 12, which is 10 power minus 3 is the option. You need to be quick with numbers. Now, question 110. Pick the statement which is incorrect. Incorrect. Hold on. Pick out the statement which is incorrect. Please note this is a trap. Incorrect, not the correct one. In usually our mind processes this as pick out the statement which is correct. No, you're asking incorrect. So whenever you read incorrect, there's a hack to do this. The hack is whatever statement you read, I repeat, whatever statement you read, negate the statement. Take ulta of that statement. What is the first statement? Electric field lines forms closed loop. The ulta is electric field lines do not form closed loop. So when you take the ulta of the statement, check whether the statement is correct or not. If it is correct, that is the right option. For example, the first option reads, the electric field lines forms closed loop. I take ulta. The electric field lines do not form closed loop. Is it correct? Yes, electric field lines do not form closed loops. So the right option should be A. The hack is wherever you see incorrect keyword, this may be useful in biology also. Incorrect keyword, you negate the option and then check whatever negated statement you get, whether it is correct or wrong. If the negated statement is correct, then the option, whatever you have checked, is the right option for the question. Right? Let us see how this works. Field lines never intersect. What is the negation? Field lines intersect. Is it correct? Of course not correct, because field lines can't intersect. So B option is wrong. The tangent drawn to a line of force represents the direction of electric field. What is the negation? Does not represent. Does not represent. Is it correct? It does not represent. No, it actually represents. So no. So this is how you go with incorrect tagline. Please read the trigger words, the keywords, the question properly before marking. Okay. So the right option to 110 is electric field lines forms closed loop because it is incorrect. It never forms closed loop. So this is the electrostats part in a NEET paper. I hope you have got quite a lot of strategies, problem solving strategies, as well as shortcuts for the questions listed. Thank you very much for your patience. For the next NEET test, all the very best. Take care and bye-bye.